Good evening, everyone, and welcome to tonight's MLA Productivity and Profitability webinar. These webinar series are run to let producers know what's up and coming in the industry and to provide some extension on some research that MLA has been involved with. So tonight we're joined by Gordon Refshauge, who is going to talk to you about reducing kid loss in meat goats. Just before we get started, I just want to run through some housekeeping for tonight's webinar. You should be able to hear me, but we cannot hear you. There should be a control panel on the top right corner of your screen. On that control panel, there is a red arrow button on the top left that collapses and reinstates the control panel. Please type your questions in the box provided and we'll attend to them at the end of the session. So please make the questions succinct so I can relay them to Gordon at the end of the webinar. So tonight we're joined by Dr. Gordon Refshauge. He is a small ruminant reproduction scientist within the New South Wales DPI. Gordon started working with the DPI in 2008, managing the sheep genetics information nucleus flock at Cowra for the sheep CRC. Gordon has been involved in sheep research projects in the fields of genetics, nutrition, meat science and reproduction. He has interests in the thermal environment for its effects on reproduction outcomes, such as how hot or cold weather affects reproduction, and is also interested in disease and vaccines research. Gordon commenced working with meat goat research for the first time last year. Very exciting for you, Gordon. So without further ado, I will hand over to Gordon to get started.
Okay, how's that screen, Hilary? Is that fine?
Yes, that looks good. That's your PowerPoint screen.
Okay, wonderful. Thanks very much, Hilary. And hello, everyone. Thanks for making the time to listen to our webinar. As Hilary said, I'm new to the goat industry, but freely admit I am a fan. I really have enjoyed my time working with goats and, of course, as always, working with producers and industry representatives. And I'd like to acknowledge that MLA funded this project with grower levies and that the project couldn't have been delivered without my co-investigators at Charles University, as well as the support I've had from within New South Wales DPI. The origins of this project are found in the comparison of recent estimates of the cost of diseases to the cattle, sheep and goat industries. What stood out from that work was the absence of reproduction costs to the goat industry. For example, let's consider the cost of perinatal mortality to the sheep industry. Perinatal mortality includes the cost of the death of ewes and lambs, and in 2015 was estimated to cost $540 million, which was around about 10% of the gross value of sheep meat and the wool industries. The most recent estimate for perinatal mortality in the sheep industry suggests it may be approaching $1,000 million, which is $1 billion. In the slide on the screen, there are 6 arrows and they each point to a disease that affects sheep reproduction. This is the cost estimates for the major diseases affecting the goat industry. So when we consider the important costs affecting the goat sector, we find only one disease affecting reproduction, which is pregnancy toxemia. And far and away the most important cost was considered to be internal parasites. But unlike sheep and cattle, the loss of young and breeding stock did not feature. The way this report estimated the cost of a disease to each industry was to survey producers and veterinarians of the cattle, sheep and goat sectors. The authors then took the most important diseases, turned to the literature about their impacts and developed cost models at the farm level. Those costs were then extrapolated back out from the herd to the industry scale. So the first question when we think about the costs affecting the goat industry becomes, are the assumptions behind these costs correct? The surveys of producers included 30 people. Those producers were located evenly across all of the goat producing states. This doesn't reflect the distribution of goats between the states where there are large goat populations, for example, mostly in New South Wales and Queensland. Furthermore, most goats are in the wild harvest regions for which there will be very limited recorded information. So in view of all of these, the next question becomes, was the survey skewed or was it spot on? Is reproduction an important cost to the industry? And that leads us to this project. We are contracted to deliver more than what I will talk about in this webinar. Things that I'm leaving out include state laboratory disease investigation summaries and a bioeconomic farm model that examines the farm level impact of goat reproduction. We're still working on those aspects of the project, so tonight's webinar focuses on the context of the review of literature, what we think the cost of kid mortality could be to the industry, what we found in our pregnancy scanning work and our producer interviews. And then I'll pull together the key take-home messages and offer an indication for my thinking around where the industry goes next. And so, to the findings of the literature review. Although the project is titled Reducing Kid Loss, it was clear very early on that we needed to consider all aspects of goat reproduction, not only because that provides a useful context, but it was also important for the cost estimates that I'll come to in a minute. The literature includes a wide range of breeds and nations around the world that have provided that information. And the key observations are as follows. The goat is a seasonal breeder. The optimal time of mating is April to August, but mating will successfully occur from March through to September. The length of the estrus cycle is 21 days. So that should mean a mating of 2 cycles should last for 6 weeks in a managed system. But there are examples of shorter and longer estrus cycles. Pregnancy rates are high when mating occurs during the breeding season compared to out-of-season matings. And it's also important to note in the very first row there in that table that the age of puberty can commence from about 6 months. Puberty is defined as the time of the first ovulation. So young females can stand in heat, but if they're not ovulating, they haven't reached puberty. When they ovulate, they can get pregnant, and therefore they've reached puberty. If a young female is born to a doe mated in the optimal time of mating, that young female will reach puberty earlier than if its mother was mated out of season. And young females will reach puberty earlier if their growth rates are faster. The goat is a fecund species. Fecund means it will give birth to many young. Twins and triplets are common, as you will all be aware. When compared to adults, maiden does will have fewer kids in their first parity. Parity means pregnancy. And to get the most out of these features, matings that occur in the optimal breeding season will have much higher ovulation rates, up to 40% more eggs produced per ovulation. Unless we do a laparoscopic investigation, we can't tell what the ovulation rate is. And so to estimate the potential number of kids per pregnancy, we need to be using pregnancy scanning. So on the screen, we've got boar does averaging around 1.6 to 2 kids per pregnant doe, and the literature suggests it's around 1.7. And for the rangeland doe, the average number of kids born in the literature is actually really very high. Reproductive wastage can be defined as the difference between the number of eggs a female releases and the number of kids surviving to marking or weaning. That's the total reproductive potential and any losses therefrom. Losses can occur at fertilization or during embryo development and implantation. So that's when the embryo sticks to the uterus and commences the placental development and the confirmation of the pregnancy. You can have losses of fetuses during the pregnancy from mid to late, and you can also lose the kids around the time of birth. As ovulation rate increases, the potential number of fetuses can be lost also increases. During pregnancy, factors such as low nutrition, leading to weight loss in particular, can increase midterm abortions. Those in lower body condition score are also more susceptible, and so too are the maidens and the oldest does. So those that have had more than 5 parities or 5 pregnancies are at higher risk. Around the time of birth, we have our most important period of losses. These are pregnancies that are carried to term and then lost. So those does have eaten for all of those 5 months and then failed to realise or convert, I guess, in some crude way, all of that grass into a live young. There is variation in the loss rate according to region, litter size, nutrition, and breed. Low nutrition and litter size are the things we can take into account and to try and manage during a pregnancy. So if we knew a doe was carrying twins and we knew how to manage maintenance or sub-maintenance nutrition, we could make some decisions around our management within the pregnancy. Of course, we can't change breed during the pregnancy or our location. When compared to sheep, for example, the mortality of twins in goats is quite low. And as with sheep, the loss of triplets can be very high. It's a very large range. But at the low end, that's quite a low level of mortality at 18% in the triplets, as you can see my arrow on the screen. So there's a big range. The risks of kids being lost is magnified when we have situations such as triplet does and low nutritional conditions, which is really why pregnancy scanning is so strongly advocated by the industry. In completing the review of our literature, it is clear that a well-managed operation can wean very high rates of kids with high levels of fertility, high levels of litter size or kids being born per doe, and very high levels of kid survival possible. This suggests that timing, scanning, and management are your key tools to become more successful at rearing kids. Having completed the literature review, we've taken that information, as well as other published information on does and numbers and price from other places, and we then worked on what we thought the cost of kid loss was to the industry. Before I move on from perinatal mortality, let's make a comment that there really wasn't very much information in the literature about cause of death of newborn kids. And what's interesting for everybody is that there wasn't a large amount of emphasis on predation in the available literature. It tended to focus more on starvation, mismothering. Now this slide is going to be busy. So when undertaking economic estimates, we've had to make assumptions about things like the size of the population, the price of the commodity, and the loss rates. In our work, the assumptions that we made include that there are the same number of meat goats in the managed sector where we have population counted, the same number in our model as there were in 2015 and 16. Now, it won't be the case because of the recent droughts, but there's no more recent information around the size of the doe population, and so it is at least rational and defendable to refer back to the most recent estimate. At that time, the population of managed goats was 425,000 animals, and it didn't include rangeland goats. For our model, we presumed that 46% of goats were breeders, and we removed dairy and mohair goats from that population. We also used a 5-year average meat price, which was $5.41. We then estimated the level of kid loss which we started at 20%, and we considered that a benchmark of best case scenario was 10% of kid loss. We then used pregnancy scanning information results that came from this project to instruct us to set fertility at 71%. The figure on the screen is the current value of production foregone due to low fertility rates and kid loss, and it's limited to the managed meat goat sector. Now I'll just scroll forward on my screen and start drawing. I'm going to draw with a highlighter. Okay, so to read this, we have fertility in orange at 45%, which is around here, down to here. We have fertility at 71%, the blue line through here, and fertility model at 95%. We also have in this model kid loss, so that's the mortality of kids at 20, 30, 40, and 50%. What these lines tell us is that as we firstly improve fertility, the importance of kid loss becomes greater. So the amount of money the industry foregoes increases. They start fairly close together and they've spread out. So kid loss is much more important as fertility improves in the sector. When we ran these models, we were operating on only literature and small amounts of real-world information. And as we've got to the end of this project, we now know that kid loss is around 35%, which in that text box underneath I've got is 65% survival. At around this level, with a fertility level of 71, which is what our pregnancy scanning results are telling us is happening, we have around about a cost of kid loss to the industry of $3.63 million. Oops, I'm going to have to erase that. Erase all drawings. So when we also then consider that there are economic gains to be made by improving fertility rates, because our pregnancy scanning, for example, suggested that we were only at 71% pregnancy. If we were to improve our pregnancy rates from 71 to 79%, that would improve the value of the industry by another $1.3 million. Now remember, that's the managed doe sector. We have a population of managed animals at around 425,000. We have 46% of that population, we believe, are breeding does. So that gives us a population of 195,460 breeder does in the managed meat goat sector of the Australian goat industry. If we were to improve survival, it would equate to something like $18 per doe. And if we were to improve fertility, it might result in about another $13 or so per doe. So taken together, these two estimates suggest we may be able to improve the value of the industry by $20 to $30 per doe. That's on a base price of $5.41. So when we consider these findings against those of the 2015 report on the goat sector, our economic estimates suggest kid loss is the most important factor. Now, before I get shot down here, because I know what I've done, I'll point out that in the report by Lane, it was published in 2015 when goat meat prices were lower, but we would have had a similar population in our model to their model. Meanwhile, of course, cost structures of businesses will have changed a great deal. And so what I'm doing here in this slide is not comparing apples with apples. Nevertheless, what this suggests is that kid loss has the potential to be, and is most likely, a significant and important cost to the industry, and it should rank in on this slide, and it will have to be much greater than all of the diseases after internal parasites. And I'd be confident to say that it could be as important or more important than internal parasites, based on the data we've collected this year. So we'll look at the data we've collected this year, because it was quite a drought, and quite a drought in a large area of the goat breeding regions. So this map is taken from work produced by my New South Wales DPI colleagues, Trudy Atkinson and Warren Smith. It shows the production zones for the goat industry and the number of animals in those zones. You're probably looking at the screen now trying to find out where you are. So I will just draw on here. So I won't draw, I'll just point. In production zone 1 is the rangeland, predominantly wild harvest, but has some significant production from extensive semi-managed and managed enterprise. Production zone 1. Production zone 5 is almost strictly wild harvest. Production zone 2 is northern high rainfall. Production zone 3 is southern high rainfall. And then in production zone 4, we have southern high rainfall in South Australia and Western Australia, mostly small scale. So we get a sense for the number of animals in those zones and where those zones are found. So we tried to select our producers to represent the populations and producers from each of those zones, both in our case study surveys, but also in our on-farm pregnancy scanning results. And so this is what some of our results are looking like. This table reports a summary of the pregnancy scanning results for doe age. On some locations, especially early in the project, it was clear that the mated does that we were pregnancy scanning included young adults and at times weaner kids that were exposed to the bucks. Given all females were being scanned, it became clear that we needed to identify doe age. So after the first property or so, we ended up with populations of known adults, known maidens, and mixed sex, where the age was not recorded against the pregnancy outcome. The goats were mostly boar, but there were rangeland, Angora, rangeland cross Angora, and boar cross Saanen. For adult does, fertility at 81% was lower than the literature suggests, while the kids per pregnant doe, which is kids per wet doe in that table, was about the average reported for boar and lower for rangeland estimates. When we look at the bottom row for maiden does, which does include weaner kids exposed to bucks, fertility was a problem, very low at 48%. Notwithstanding the low fertility, the number of kids per wet or per pregnant doe was as high as it was for adults. That's a very interesting response. Kid survival is calculated as the difference between the number of kids counted at the time of marking from the number of kids or fetuses that were scanned in mid-pregnancy. Our estimates show that kid survival in adults is lower than the literature suggests at 70%. In particular, the maidens are having a real problem with very few kids being reared. Now, I've highlighted maidens here in yellow because we only have 4 farms providing that data. Now, of all the farms that we had maidens recorded, half of them were able to kid their maidens down separately. That's from where we've extracted this data. So when maidens were about 22% of all scanned does, and then we have 22% multiplied by a fertility of 48%, multiplied by a survival of kids of 35%, it's possible that maidens are rearing no more than 4% of all the kids, and yet that comes from a population of 22%. This is a problem for the industry and suggests that exposing the young doe to bucks just to get a few more weaners could be a mistake, particularly around resource allocation, particularly in droughts. This is an opportunity for further investigation. When we consider how the performance on farm varied between the regions, this table summarises that quite well. Remember, we have the rangeland zone in production 1, high rainfall in production zone 2, that's northern, and high rainfall southern in production zone 3. This is where all of those producers were engaged for the scanning component of the project and included properties in Queensland and in New South Wales. The averages are weighted means, which allows for the differences that we get in herd sizes. My take on this, firstly, is that doe survival is very good. Fertility can be greatly improved, and presuming a return to normal seasonal conditions should improve into the future. There were very few operators that were mating outside the normal breeding season. There were some, but their effect on these figures is minimal. Kid survival varied greatly and on average was low. We had one location with very high survival at 93%. And at that location, there was a lot of grain feeding and the lucky falls of some good autumn rain in mid to late or mid-autumn. On the screen, you can see kids marked per doe scanned in that far right column. And the range at the bottom there is between 37 and 130%. That's a range of 93%, which is astronomical. What that tells me is that the potential is there to mark per doe scanned very high percentage. But when things unwind, they unwind in a big way. With our co-investigators at Charles Sturt University, we had an honours level student, Maddie Brady, undertake surveys of producers, which were 20 in number. These interviews were with people right across the nation and in all zones. Most producers were in the rangelands and northern high rainfall zones. The average producer age was comparable with other industries. The properties were on average large operations. The primary findings from this survey work that stand out to me include a common view that there is a lack of specific information available for producers around goat production. Generally, there were many comments suggesting that district veterinarians weren't up to speed with the industry, which I think simply reflects the level of experience and exposure to goats when compared to the level of exposure to sheep and cattle problems. So that may be an experience issue rather than a training issue, and may or may not be a fair comment. Kid loss was felt to be an important issue amongst the producers, which is a finding that may be in some way biased by the fact that we were interviewing growers in relation to a kid loss project. Nevertheless, the growers estimated their average kid loss, and that came out to average at about 28%. In the very tough conditions of 2019, the kid loss was 35%, and we still have 2 properties to provide some more information to refine that number. Predation, doe nutrition, and mismothering of newborn kids were felt to be the greatest sources of kid loss, and all producers recognised that kids were lost in the first week of birth. Some of this, in particular, the loss of kids in the first week of life, reflects very well with lamb mortality. So too does doe nutrition and mismothering, and predation in the sheep sector certainly varies a lot between properties. In the literature, predation is recorded and can be variable, but doesn't appear to be the most important issue. So there we have some evidence of divergence between the views of producers based on their experience and what's been recorded in the literature. So there's a gap for further exploration. This is my 4th last slide and my conclusions. The points I've really focused and emphasised on about fertility and the importance of that. But in particular, the reproductive success of the maiden is very low. When we consider that 22% of the does scanned were maidens and that they may be rearing only around 4% or less of the kids, then there is a big issue. The ability of the doe to abort in a fetus in mid and late pregnancy is a concern to me. It's a characteristic of the goat, and that needs further investigation. What it means is that getting feed budgets right, estimating feed in a paddock is important. Managing shy feeders is clearly important during times of drought, and so too is being a good judge of body condition score, because these are the factors that will help manage and minimise abortions. 2019 was a tough year for most, and the results we've got might change over time. Looking to the future, I believe there will be value for the industry in further research examining breed suitability and breed crosses. There are some interesting things happening in the industry that are being tried on a small scale and that have wider application. The impact of the 2000 until through to today, the drought of 2017 through to today, has had an impact on these results when compared to the published literature. To put that into context, I think sentinel farms would be very useful for the industry, as these would be in locations around the production zones where lifetime production information could be yielded to help industry understand the value of transitioning from wild harvest to semi-managed systems and from semi-managed to managed systems. Sentinel farms could also be a useful place for systematic cause of death investigations to get a better sense for the primary cause of death and hence direction for future management to minimise their prevalence. A final comment, which is completely out of scope for the project, but what I found was that there was a great range in the quality of handling facilities. Overall, pregnancy scanning dose requires a great amount of labour, and that will be a barrier to wider adoption of pregnancy scanning and a major cost to production. So it is valid to continue to look at those handling facilities. Just want to acknowledge Trudy Atkinson, Fiona Scott and Robin Heen of New South Wales DPI for supporting the project, Bruce Allworth, Michael Friend, Marta Hernandez-Javert, Susan Robertson at Charles Sturt University, and Maddie Brady, the CSU student the CSU honours student. I'd like to also thank the cooperator pregnancy scanning producers, the pregnancy scanners involved in the project, and the producers supporting the case study. I think we've done a pretty good job pulling this together. I'm very happy with the information that we've got. It lines up very well. Just on a final comment, this is the final slide. There are 2 papers being prepared for submission from this study currently, and I think I may be able to squeeze another 2 more papers out from this, which is a pretty good success rate. And the comment made earlier in the producer surveys that there wasn't a lot of specific information around, I thought it was sensible then to just remind everyone that if they haven't seen these resources on the MLA website for going into goats, for the video resources, as well as the fact sheets, that information there is really top-notch, very high-quality information. Hilary, that concludes my presentation. Just about 30 minutes in. Apologies for going over time.
No, that's fine. Thank you very much for that, Gordon. It was definitely worth that digging into that very informative presentation. I think it's very thought-provoking, and there's obviously been a lot of work go into the area, and there have been a number of issues identified, and I think that's a good thing because it means we can then focus on them and improve production and profitability for goat producers. Just while I give Gordon a little bit of a break, a reminder, next week we have a webinar with Dr. Paul Nylon, who is going to be talking about infectious diseases causing abortion in sheep. So that'll be a good one. Again, Tuesday night, 8 p.m, Tuesday the 25th, so next Tuesday. Just if you do have to leave early before we get through some questions, and please send them in as soon as possible. Just please, as you click out, you'll be presented with a survey. Could you just take 2 to 3 minutes to complete this survey? This survey goes back to MLA and to the facilitators at Home Circuit and to Gordon to make sure that our extension efforts are valued by producers and the people who are listening to these webinars, and to make sure that we continue to provide information that's relevant to what you are looking for. So please, as I said, send in your questions. So Gordon, I've got one to kick one off. I guess we looked at a lot of the outcomes and results of the studies, and you noted that the reason for kid losses lie in that predation, doe nutrition, and mismothering. Could you just spend 1 or 2 minutes just expanding on those points, especially nutrition, if you can, just sort of what parameters were around that, and sort of what nutrition, if they if kid loss was not an issue, what nutrition was there to make that possible, if you can?
Okay, so I think the best way to answer that question is to talk about the value of nutrition and why it's particularly important around late pregnancy and in early lactation, critically. So when a doe is able to meet her nutritional requirements, she's able to gestate a kid of appropriate birth weight. Now, I do have slides available, but not in this presentation, that shows the relationship between birth weight of the kid and survival. And what it shows is that as birth weight increases from very lightweight kids, around the 1 kilogram, up to about 6 kilograms in birth weight, their survival improves each time birth weight increases. Now, what's interesting there is that there's a great amount of improvement in the first range from about 1 to about 4 or so, or about 4 kilograms. Very little improvement in survival after 4 kilograms. That work was produced by Michael Aldridge, and a very good little piece of work in his PhD, and suggests that improving nutrition in mid and late pregnancy will improve birth weight, and particularly for the lightweight kids, and apparently appears to have no particular penalty as the birth weight continues to increase. So if we improve nutrition in the late pregnancy, in particular, we increase birth weight, and that is associated with better survival. Now, part of the reason for that around when we look at the cause of death is that a kid that has a higher birth weight has a greater amount of fat resources to turn to when they're waiting to get their milk, and they can use those fat resources to create heat and energy, and that allows them to buy some time. If the doe is on appropriate nutrition, then she has enough energy to continue to push out the kids during the parturition, during the birthing process, but she will also have better quality colostrum and a better milk yield. So nutrition underpins birth weight, milk quality, and milk yield, and all of those things come together to improve the survival of kids. That in particular is the most important thing about doe nutrition around that critical time of survival. So getting it wrong can lead to, so we see live weight loss in late pregnancy, we start to get abortions, and when the does are kidding at low nutrition conditions and are in low condition themselves, we start to have lower birth weight kids, problems with milk, longer birth processes, and all of that conspires against the kid and increases mortality.
Thanks, Gordon. I haven't got any more questions through yet, so I'll just ask another one. So please type your questions in the question box for Gordon. He's got a wealth of knowledge, and I'm sure he'll be happy to answer anything relevant to the topic, and it's a really good opportunity to ask any questions that you may have. So with the pregnancy scanning results from the project, and you were talking about the low kid survival in maidens, Gordon, do you have a recommendation coming off that? So I guess with sheep, you might prioritise their, looking after them at joining or at different points of their reproductive cycle to make sure that they are getting those lambs through. So is there identified recommendations coming out of that result?
Yeah. So what I think is, so firstly, it's just important to state that, just to refresh and remind everybody that in some locations there were weaner does being exposed to the bucks where they may have been 7 months or 6 months of age, and the pregnancy rates in those sorts of animals are generally very low anyway, and there are other factors that might affect the expression of and the development of puberty could be influenced by the time those does were also born and their growth rate to joining. So there may have been underweight does being exposed that were young and not likely to be, may not have reached puberty. We don't know that information. So that is a part of background data. But even on well-managed properties, we still had a higher proportion of does that were maidens, even as they were kidding as 2-year-old maidens. We still had a high proportion of those failing to rear their lambs. So taken together, when we look at and consider a farm system when we've got all the females in one paddock being exposed to the bucks at one time, and then pregnancy scan them and put them all in the better paddock for kidding, and you've got animals in there that have a much higher nutritional requirement because the maidens are still growing animals. Those females are all competing, particularly the maidens, are all competing for the same feed resource. When you've got a proportion in there, which could be quite a lot of animals competing for a feed resource, and when those animals then don't perform by rearing your kids, then they've detracted from the whole operation. And so my thinking there is that maidens should probably at the very least be kitted down separately to the adults. They should be kitted down in probably the better quality feed that you've got at this stage, I would say, particularly given that their scanning rate is about the same in terms of the number of females and the number of kids that those does are carrying. My thinking is that if you have them separated, you should allow them to have better nutrition, which should improve the feed resource available for them and improve their condition and all their outcomes. Why exactly they're not performing the same or as even similarly to the adult does needs to be looked at a little more carefully, because they really stood out quite seriously at all locations where we looked at the udders, number of does rearing kids. They were really standing out. Very few of them were really getting pregnant, and then very few were rearing, having got pregnant. So they need a different management system. That's clear. Exactly what that system is, I'm not too sure, but it would certainly revolve around space and feed.
Excellent. Thanks for that, Gordon. So a few questions have come in now. One from Colin. Do you think that genetics plays any part in kid survival?
It's a great question, Colin. Yes, it does. You've got, when we look at the sheep literature, it is the contribution of the female to lamb survival that is some of the biggest components. There is variation between sires for survival. And so there is a component there for the selection of the sire to improve kid survival. And the role there around the sire might actually involve birth weight more than it involves some other innate genetic relationship with survival. And so I think genetics does have a role, both through birth weight selection and through the selection of females for their ability to rear kids.
Thanks, Colin. Thanks, Gordon. So next question from James. Did you form a view based on your field work of the suggested percentage of adult weight that maidens should achieve before being joined?
Yeah, that's a good question. The answer is from the literature, 60 to 75% of the adult weight is the weight you'll get puberty in the weaner doe. So in the boar, that might be between 27 and 31 or 32 kilograms. So I would imagine then for a hogget, so that's a doe to kid as a 2-year-old, that animal would want to be somewhere around 80% of her mature weight to successfully conceive. And any great departure from that will lead to much less successful outcomes.
Great, good question, James. Thank you. The next question from Kerry. If practical, would it be worth removing one of the triplets?
If you've got the time and you've got a doe that you can that's having a single that you can place onto, yes, you would take the lightest weight triplet if you've got the resources. In the semi-managed and extensive systems, obviously that doesn't have a role, but in the intensive systems, yes, it's the lightest triplet that will always be the most vulnerable. And studies from sheep where they've examined a disorder called intrauterine growth restriction, which is basically poor placental connection, and the lightest triplet is gestated poorly and has a very low birth weight. The mortality rate in the field of those animals is extremely high, but as studied by my colleague who's also done work in goats, Paul Greenwood, his PhD pulled aside these very light little lambs and kept them warm and fed them. And he had very high success rates, really very high success rates. So I would imagine exactly the same thing will happen. Take the lightest triplet off and put it onto a single doe, keep it warm, free of disease, and as long as it's suckling milk, shouldn't be any problem.
Great. Thanks, Kerry. Thanks, Gordon. Next question from Matt. Did you look at the buck percentage affecting scanning results?
That's a really good question, and no, I didn't write that down. Some of our scanning operators, some of our producers were in some extensive systems, so we were collecting does at depots. I would have written down notes, but I haven't collated that for this presentation. It's a really good question, and I actually can't answer that one.
No, that's fine. That's what there will definitely obviously be more research in this space. So and MLA are good at providing resources and the papers for the study. So make sure you keep an eye on this area. The next question from Helen, did iodine deficiencies show in any of these studies?
So iodine deficiency is particularly important for the goat because it relates to the temperature controlling hormones. We weren't doing investigations during the studies, so we weren't looking for goiter. And goiter is the swollen thyroid gland. So I can't comment on that status. With our producer surveys, we talked about the kinds of supplements that they were providing, and there was a wide range. And we also talked about the diseases that have occurred on farm over time, and iodine didn't pop up consistently across many of the properties. So what role iodine deficiency has had is not clear, but I don't think it will be a primary function in these results.
Interesting. Thank you, Helen. Thanks, Gordon. So that's it for tonight's questions. Thank you very much to everyone who got involved and sent through a question. There were some really, really good ones there, and definitely some that Gordon will probably take through into the next lot of study. Thank you very much for joining us tonight, Gordon. It was a really interesting presentation. So that's it for tonight. Just remember, next Tuesday night we have Dr. Paul Nylon talking about infectious diseases in sheep causing abortion. So we'll see you then, and good night, everyone. Thanks, Gordon.